Okay, so this is straightforward equilibrium calculation. It is 2008. We are interested only in this part B here, where it says write an expression for the equilibrium constant Kc and calculate the value. So our Kc we always write as products over reactants. So we are putting the Hi and we put it in square brackets because square brackets mean moles per litre. We're using the ratio here from the question to work out the power for our Hi. So our H2 goes in square brackets and our I2 goes in square brackets, and because the ratio for both of these is 1:1, there's no power. I always like to write out my reactants and my products as my kind of column headers. We will have to work out an initial concentration, we will have to work out an equilibrium concentration. I also get into the habit of using the ratio to find out how many X's, and the X is going to be, in the case of our reactants, they're going to decrease by, is it X or 2X? As my ratio for hydrogen to iodine is 1:1, that's going to be an X and an X value. And my products are going to increase at equilibrium by 2X. And I'm getting that 2 from the ratio in the equation. So when we scan through the question, we are looking for moles and a volume. So I have 11 moles of hydrogen, I have 11 moles of iodine. That's going to be my initial. I've got my color change blurb, and then at the very end I have 17 moles of Hi present. So that's going to be my equilibrium concentration. There is no mention in this question of litres, and if no volume is given, then we already assume that it's good to go. So I'm going to put in 11 moles here, and I can use that, and 11 moles here. And at this stage, we always assume that the products are 0 because the hydrogen and iodine haven't been added together. Please be aware that there have been a question where they actually gave you an initial concentration of a product. You just work it the exact same way. If the product has a number, then we'd assume that the reactants would be 0 and 0, and there would be an equilibrium concentration for the reactants. And the reason that we can do that is because these are reversible reactions. So we had 11 moles and 11 moles and 0. At equilibrium now we will have 11, which will be reduced by the value of X. We will have 11, which will be reduced by the value of X. And our equilibrium constant, when we get our equilibrium concentration of product, which was 17, that's the equivalent of 2X. I like to box the numbers that I'm going to put in my formula, because here we have to work out what the value of X is, and a lot of candidates get confused and decide this is the last number I've written, this must be the one I put into my Kc, and they're obviously incorrect. So we have going to use the value of X, and we're going to put it in here and in here, and when I do that, I am going to get 2.5, 11 minus 8.5 is equal to 2.5. And these now are the numbers that I'm going to input into my Kc equation. So here Kc is going to be I just did it, 8.5, it is not, it is going to be 17, and that is going to be squared, and I'm essentially going to have 2.5 by 2.5 here. If you can, this, instead of writing it like this, write it like this. So recognize that it's 2.5 squared, because when we have to use our square root method, it's really important that you recognize that these are both squared, so I can square root both of them if I actually had to. Okay, so when I put that into my calculator and I work it all out, I get 46.24. Technically, because of the way the question is set up, there's only 2 significant figures throughout it, so 46 would be your answer for this. Again, always check that you've answered the question asked. This particular question was very straightforward, because it's only asking you the value of your equilibrium constant, but always double check that you've answered the question asked.